Okay, so in the previous video we were talking about phase angle. So phase angle is nothing but angle between two quantities. Those quantities are like voltage and current or something like that. Now you can say, you can define another way is, it gives us the time difference between two waveforms. So if you look at here, I have a voltage waveform. Okay, say it is reaching its maximum value. So if you take f equal to 60 hertz, okay, f equal to 60 hertz, it is reaching, so this must be 16.66 seconds milliseconds, 8.33 milliseconds, that is 4.17 milliseconds. So it is reaching its maximum value at 4.17 millisecond. I'm representing this in seconds, but usually it's going to be in theta, okay, with the degrees or radians. Okay, so now if the next waveform current is going to start, say, from here, what is the time difference between these two? Okay, that tells us the phase angle. Okay, that's what the phase angle is. So it gives us the time difference between two waveforms. Time difference between two waveforms. That's phase angle. What is phase? Okay, phase usually represent with phi. Phase angle with theta, phase we represent with phi. Phase is nothing but physically it is a coil. It is a coil in a generator. Okay, so phase represents a coil. So if you look at a three phase, usually we use three phase, we'll have three coils. I'm showing you only three. In reality, there will be more coils connected in series or parallel combination, okay, based on the requirement. So all the coils are going to spread all over here. Okay, but I'm representing only all those coils into three coils. Okay, so phase is nothing but it is a coil in a generator. Next quantity is RMS value. Okay, RMS means root mean square. Okay, RMS value is nothing but root mean square. This RMS value is defined based on the energy transfer. That energy, you can say heat. Okay, based on the heat transfer. Now say for example you have a 1 liter water. Okay, that's a 1 liter water. Okay, so here it is a 1 liter water. Okay, now we want to change the temperature of this water or increase the temperature of this water by 1 degree centigrade. Okay, and assume that it took around 1 minute. Okay, so this is 1 liter of water. We are raising this 1 degree centigrade, the temperature, say 36 to 37. So we are raising the temperature 1 degree centigrade in 1 minute. When we connect this to a DC source, here I'm connecting a DC source, those are the electrodes and resistance. Okay, so we spent some energy. Now when we connect the same amount of water, same 1 liter water, and we are increasing temperature 1 degree centigrade in 1 minute, the amount of AC current or AC voltage needed is called the equivalent amount of AC voltage or AC current needed to change this temperature in the same amount of time is called the RMS value. So RMS value is based on the heat or energy transfer. Okay, so if you take V of t equal to V max sine omega t. Okay, or I'm going to take it as theta for time being. Okay, now what is mean value? Mean value is nothing but, so a sinusoidal waveform is changing from 0 to 0 pi 2 pi. Okay, so mean value is nothing but 0 to 2 pi. Oh, this is mean square value. Okay, not mean, it is a mean square value. Mean square value is 0 to 2 pi v of t whole square. Okay, that v of t equal to v max. V max is independent of the quantity, so sine theta or sine square theta. V max square sine square theta. So this is mean is nothing but the average, right? So I forgot to put that average thing, v square over 2 pi minus 0. So we'll end up with 2 pi minus 0. Now RMS value is nothing but root mean square value. That value is RMS value equal to square root of 0 to 2 pi v max square sine square theta d theta over, did I forget to put this here? There should be d theta here. Okay, there should be d theta there too. So v max square sine square theta over 2 pi minus 0. Now I can write sine square theta equal to 1 minus cos 2 theta over 2. Now after substitute and solve this example or solve this integration, we will end up with v RMS equal to v max over square root 2. Whatever we solved for, that's a sinusoidal waveform. So v RMS equal to 0.707 v max. This is for sinusoidal. Now we have the RMS values for other waveforms. I'm going to write down. Okay, so RMS value for the square is VRMS equal to Vmax. For a sawtooth waveform, VRMS equal to 0.577 Vmax. Triangle equal to VRMS equal to 0.577 Vmax. And sinusoidal waveform, VRMS equal to 0.707 Vmax. Okay, so those are the relation between the maximum values and RMS values. Remember, this is valid for current also. So I can write this as IRMS equal to 0.707 Imax. Okay, so it is valid for either currents or current voltages. Now the next one is average value. So average value, it is based on charge transfer. It is based on the charge transfer. So here I'm going to use the current and stuff. So I equal to, or I of t equal to I max sine omega t or theta. Okay, so average, when it comes to average value, if I use the whole cycle, my average is going to be 0. So what I'm going to do, I'm going to do the positive half cycle and I'm going to double it at the end. So it's going to be 0 to pi it d theta over pi minus 0. That's the average value. So this value is going to be, so if you substitute, I'm going to pull out Imax over pi 0 to pi sine theta d theta. Okay, so after we solve this, we will end up with 2 times I max over pi. As I mentioned, I doubled it at the end, so we'll end up with 0.6, this value equal to 0.637 Imax. That's the maximum current, I average. So I average equal to 0.637 Imax. Now that is for the sinusoidal. When it comes to other waveforms, so for a sinusoidal waveform, I average equal to 0.637 Imax. Square waveform, average value is same as the maximum value. Sawtooth, it is I average equal to 0.5 times Imax. For triangle waveform, I average equal to 0.5 Imax. Now, here is a question. So whenever we talk about, when we say the voltage coming out of those outlets, we always say it is 120 volt, 60 hertz, right? That's in the United States, or in India it's around 240 volt, 50 hertz. Okay, what is this 120 volt represent? Is it a RMS value, maximum value, sinusoidal value, instantaneous value? What is it? So this 120 volts, this one represents an RMS value. So in the future, wherever you see a voltage in AC, whatever voltage we are talking about, we always give them in RMS values. Okay, I say a 120 volts is coming out of that outlet, or 240 volts is coming out of that power outlet, then we'll say that value is RMS value all the time. Okay, RMS value, because that's a equivalent of energy transfer with the DC circuit. So, and we know the relation between RMS and maximum. So basically, if you look at a sinusoidal waveform which is coming out of those power outlets from our wall, it can reach, so this is the maximum value. What is the Vmax? Vmax equal to Vrms times square root 2, or Vrms equal to, you can see here, Vrms equal to Vmaximum over square root 2. So if I use the same principle, okay, Vmax must be 120 times square root 2, around 170 volts approximately. Okay, so that's the relation between RMS value and maximum value. And the voltages in AC, voltage or currents, unless I specify, we always take them in RMS values. Thank you.